Hello, I did my hypothesis testing project comparing a sample of Skyline students that uses a reusable water bottle to the UK's population statistics of owning or using a reusable water bottle. So let's start off with some facts. A survey has shown that more than a fifth of people do not use a reusable water bottle or have lost it and not bothered to replace it. The UK uses 13 billion plastic bottles a year, and only 7.5 billion of those plastic bottles are recycled. Personally, I'm a huge advocate for environmental conservation, and I strongly believe that we humans play a huge role in destructing our Mother Earth, and that's why our planet is drastically changing year after year. Plastic leads to destroying marine life and polluting our Earth. Millions and tons of plastic are polluting our oceans and seas. When looking at UK statistics, only 55% of the UK population surveyed by Keep Britain Tidy environmental charity in 2018 said that they owned a reusable water bottle. Keep in mind that's only a little over 50%. Moving on, as I said in the previous slide, only 55% of the UK's population said that they owned a reusable water bottle. The statistics given to me about the Skyline sample shows that in a total of 140 students, 111 of those students answered yes to owning a reusable water bottle. Our goal for this project is to first compare the Skyline sample to the national claim, and two, to use the summary to compare the variable with the sexes at Skyline. We know that a total of 140 Skyline students were asked if they used a reusable water bottle in this study, and we're suspecting that it would be about 55% of the sample, but we wouldn't know unless we conduct a hypothesis test. Before conducting the test, I was able to make a pie chart to get a rough idea of how my test was going to play out. From looking at the pie chart and a histogram, we could tell that the percentage of students that own a water bottle is way more than 55%. It shows us that about 79% of Skyline sample owns and uses a reusable water bottle, and about 21% do not. To our hypothesis test number 1, our null hypothesis and our HA is 0.55. We're trying to test if 55% of Skyline sample uses reusable water bottles. And since our X is 111, we found that our p-hat is 0.79. We need to know how likely it is in a random sample of 140 that 55% of the students use reusable water bottle from a population where 55% of the people use reusable water bottles. Through StatCrunch, I found Z to be 5.77. At a 0.05 level of significance, the critical value of Z is 1.65-ish. Through conducting a hypothesis test, I've come to a conclusion that since our observed value of Z is greater than the critical value of Z, and our p-value is smaller than our 0.05 level of significance, we therefore will have to reject our null hypothesis. Our proportion is not 55% compared to the national claim, and it's significantly different. This graph just visually shows us how small our p-value was. And for our next test, we would be trying to compare the variable between females and males at Skyline. I made a pie chart for both female and male data retrieved. Oh, whoops, I accidentally cut off the percentage for the female data, but about 20% do not own a reusable water bottle, and about 80% of them do. For the male data, 22% do not own a reusable water bottle, and 78% do. On to hypothesis test number 2. Our HO is P1 equals P2, and our HA is P1 less than P2. Meaning that the proportion of male that uses reusable water bottles is less than females. I conducted this test at a significance level of 0.05. Our p-hats are 0.78 for males and 0.81 for females. Using StatCrunch, it showed me that Z is negative 0.37, and we got a p-value of 0.37. In conclusion, since our p-value is greater than our level of significance, we don't have sufficient evidence to reject HO and accept HA. Assuming the population proportion of people that use reusable water bottles is 78%, the likelihood of obtaining a sample proportion of 81% happens 35% of the time. Therefore, we could say that we don't have enough evidence to say the population proportion is less than 78%. We then conclude that male and female proportion of owning a reusable water bottle is equal and not significant. Here's just another graph that shows our p-value. And the two types of errors that I'm potentially committing based on my hypothesis decisions are both type 1 and type 2 errors. When committing a type 1 error, a false positive might occur where I reject a true null hypothesis that claim is actually true and that 55% of the population actually owns a reusable water bottle. When committing a type 2 error, a false negative might occur where I fail to reject the null hypothesis of the claim, but it's actually false. If I want to prevent type 2 error, I would need a larger sample size. Next, I found the 95 confidence interval for hypothesis test number 1, where I came to the conclusion that I was 95% confident that the proportion of Skyline students that use reusable water bottles falls within the confidence interval of 0.73 to 0.86. I also did it for hypothesis number 2, test number 2, and I came to the conclusion that I was 95% confident that the true difference of male Skyline students that use reusable water bottles compared to female falls within the confidence interval of negative 0.16 to 0.11. So this last slide was just my conclusion of the whole project itself. To summarize, the Huffington Post UK claims that 55% of their population owns a reusable water bottle. Compared to our hypothesis test, our student population had a drastic difference in the proportion of people that owned a reusable water bottle, which was at 79%. Then through conducting a 95 confidence interval test, we were able to be 95% confident that the proportion of Skyline students that used a reusable water bottle falls within the confidence interval of 0.73 to 0.86, which is the lowest limit is still way higher than the UK's 55%. We were also able to do the same for test number 2, where we were 95% confident that the true difference of the male Skyline students that use a reusable water bottle compared to the female falls within the confidence interval of negative 0.16 to 0.11. So both type 1 errors and type 2 errors could have occurred with my hypothesis test. I could have rejected a null that could have been true or fail to reject null that's actually false. Sorry. If I had a bigger sample to work with, it would probably lessen the chance of me committing a type 2 error in my test. Through this project, even though the sample of Skyline students was only 140 students, I was super happy to hear that about 79% of those students actually used a reusable water bottle. If you think about it, investing in a reusable water bottle helps our planet and it helps you save money in the long run. Owning a reusable water bottle is one of the best investments I've ever made for myself because I found myself to start drinking so much more water. This data gives me more of an idea about how environmentally conscious the younger generation is compared to the UK's whole population, and I'm so happy to hear that. And here are just the source I used, which was from the article that talked about the UK's population and how much of them use reusable water bottles. But yeah, thanks for listening.